Hello fellow problem solvers. So today we're going to be doing another invariance problem from Engel's problem solving strategies book. It's problem number 55 in the example section, and I invite you to try this problem out for a minimum of 5 minutes, ideally 15, but not more than half an hour. If on the other hand you'd like to go along with this, just try it out, read it and try it out for 5 minutes. So now let's begin. So the dn is the sum of the digits of n is in base 10. And like these are some examples, the sum of the digits of 38 is 11, the sum of the digits of the sum of the digits of 38 is the sum of the digits of 11 is 2, and we must solve this. And now, I want to show this problem to you because there's really one big trick here, which is, what's invariant when you're applying sum of digits? Well, the invariant is modulo 3. N is congruent to the sum of digits of n modulo 3. And n, and this is also congruent to what? It's congruent to, just like use n is dn is congruent to d of n modulo 3. So now if all three of these numbers, n d of n and d of n, are the same mod 3, that means that when you add them, so here it implies that 3 divides n plus d of n plus d of n, and now that would imply that 3 divides 1997, which is false. It's a contradiction. So no such n exists. It's a quick little problem to show you a principle that's generally used when you have sum of digits. Let's look at it base 3, look at a modulo 3 or modulo 9. There's a problem with figuring out the last digit of, if this is a, and then the last, I believe you need to figure out what d of a is, or d of a. Something like that, where this is a. And again, thinking about what remains the same is important here. So now, with that, this solves our problem. And as always, thanks for problem solving.